Three Rivers Physics 2. So this is Professor Martineau here. Here are my lovely digs here in Cranston West. Oh boy, far cry from Three Rivers facilities, but your lab today is on the speed of sound. So first of all, I'm not sure if I mentioned it before, but the lab sheet says that you'll be testing 7 frequencies. I don't have 7 different tuning forks, and I don't have tubes long enough to fit them. So we're only gonna go to 4. So if I didn't mention it before, you're only testing 4 frequencies. So again, what we have here is what we learned from our lecture is that we have a closed tube resonator here. There's a relationship, I'm not going to go over the relationship right now, between the standing wave that we hear generated inside of the closed tube resonator, the wavelength of the sound, the speed of the sound, the frequency of the sound, and the length of this tube. And the key part here is that you have to hear that standing wave resonance. And I probably described it in the lecture, and if I didn't, I'm sorry. But basically what we're looking for is you're always going to hear the sound, but the resonant frequency is when you hear the sound the loudest. It's almost like a sweet spot. And when you hear that resonant frequency, that very loud, echoey sound, we have now created a standing wave of air inside of this closed tube. So I went over that in the lecture previous, and the equations that accompany this are here. Again, we're only looking at the first harmonic, not the third, the fifth, the second, or the fourth, only concerning ourselves with the first harmonic. Mainly because the other harmonics are there, but they're very quaint. Quaint? They're quaint. They're doilies, they're flowers. They're very quiet. So I'm not even going to bother trying to do that. All right. So our goal here today is I'm going to hit the tuning fork of a known frequency, and I have a column of air here that I'm going to change the size, the height of that column of air by either adding or removing water until I hear the sweet spot. Once I hear the sweet spot, I'm going to measure that column of air, and that's the data that you need to write down. All right, so that's generally where we're going here. So the first one is 256 hertz. So this is middle C, 256 hertz, and we're gonna bring it in. So I don't know that that's perfect, but you can hear that it's louder. So what I'm going to do is I'm going to adjust this a little bit. I'm guessing here, I'm going to lose a little bit of water.
How do you know?
I'm guessing.
Okay.
And if it's not right, I'm going to add some water. So let's hear it again. It's pretty loud. So I'm going to record that one. Hold on a minute. Sorry, stay right there. Just because I'm going to hedge my bets here, and I'm going to say that that's the good one, and that's at 32.10 centimeters. 4 significant figures. 32.10 centimeters. And just to make sure that I'm not way off base, I am going to fill this a little more, just to show that the next one will not be as loud, or hopefully. And if it is, we're going to ignore it. See?
It's not as loud.
You can hear it, but it's not as loud. So we definitely hit the sweet spot on that one. All right? Next one we're going to do is 500. So 500 hertz. So here's 500. Okay, 500 hertz. And we're going to use, I think I designated that tube. Hold on a minute. Nope, it's this one. All right, so we're going to go to this tube right now. So let me move that to the side so I don't confuse it. Okay, so this one's going to be 500. And first thing I'm going to do is remove a little bit of water, so we can kind of work up to it. Okay, and see what we get. It's not great. So I'm going to add a little. Try it again. You hit it harder. I think that's the best I'm going to get on that. I am going to measure it and then test, because you're not going to get super results, but you should have heard it. And we have 16.90 centimeters. 4 significant figures. 16.90 centimeters. To prove my point, we go a little bit way over the estimate, and we're gonna listen. Oh, that one's better.
Oh, that's better.
All right, we're gonna kill that. We're gonna get new data. Check that. That one's better.
That was really loud.
It was really loud. So I've got 15.10 centimeters. So change that data point to 15.10 centimeters. I'm actually gonna stop there on 500. All right, so let's move 500 out of the way. Next one, 1,000. This one's pretty difficult to hear. So I have 1,000. All right, so let's see where I'm at. So I'm gonna need a little more than this. I'm gonna start right about there. 1,000 hertz. It's trying. It's going to be real hard to get these tines to generate enough energy so we can hear it. But let's try one more time. I'd say that's the best we're going to get that one. So we're going to measure that column of air, and that is 8.45 centimeters. 8.45 centimeters. And that was 1,000. Now we're going to backtrack. And only doing that because I only just found this one, 320. Okay, so again, it's out of order, you'll make it. So 320 hertz, okay? So let's see, I think it's gonna be this one. Let me lose a little bit of the water. All right, so let's come on and we're going to this one right here. So that's pretty good, but I am gonna try to fine tune it a little bit because this one's louder. So I think I can mess with it a little bit because it'll be very easy to hear. So let's try it. Is that softer?
I think it's softer.
It was a little softer, so I'm going to lose some of the water. A little bit. You know what's different? It's warmer in this room than my room.
Yeah, it is warmer. Yeah. You've got
warm.
expanding
Do we have a thermometer in here?
expanding water. Somewhere.
All right, that'd be nice.
Yeah.
If we had one. What
It's
would you
about-
say,
it's-
25C?
Oh yeah.
It's over 20 in here. 'Cause
Yeah.
Her room
Oh.
actually has heat.
It's probably about 82 degrees in here.
So, all right, so let's guess about 80 degrees.
Mm-hmm.
Just for the record, in case we need to adjust our calculations because the speed of sound is dependent upon temperature.
Yeah.
So let's go ahead and say it's 80 degrees Fahrenheit,
Sure.
and that might be a factor in our eventual calculation of the speed of sound. That was louder than before, so I'm going to go ahead and say that that's the height. And that is 24.70. 24.70 centimeters.
For which?
That is for 320 hertz. Okay? So, again, that's really interesting because,
Yeah.
truth be told, I needed to have some kind of, I didn't just guess, right? I kind of figured out how much water I needed to start with, otherwise we'd be here all day. So I kind of pre-calculated at least kind of the neighborhood of the columns of air. I have a cheat over there, right? But I did it in my room, which is far cooler than this room. So my initial calculations are incorrect based on these, which is why I was surprised at some of our results because I'm like, oh, that's more than I expected. But now I realize why, because it's so warm in
It's
here.
warm.
So when we do our calculations, maybe we want to put somewhere or somewhere in the abstract of the conclusion that it's 80 degrees Fahrenheit in here about. We actually have to open the windows. So, all right, so that's all the data. Hopefully you have all of that. The data sheet that you have doesn't give you the lab format. I will go over the lab format. Those that have had me before know the general lab format. If you haven't, I will remind you. So the sheet that you have in Teams right now is just what questions you need to answer, what graphs you need to graphs you need to generate, but that is not; those are not the lab specifications. I will go over those with you. So hopefully you enjoy this. Hopefully you heard it. This is the best we get for online labs. So I'm going to try to do as much physical labs as possible and try to avoid simulations as much as I can. Can't make a promise. So have any questions, please email me. Hit me up in chat and Teams. Like and subscribe on YouTube. Hit me up for some cool merch. No.
You have merch?
No, I don't have merch.
Huh.
Anyway, so thanks guys. I'll see you next time.